the second week, okay, from the last week. Our focus today also a little bit more on geometry, okay, geometric modeling. So far, we have looked building information modeling using Revit, family editor, Dynamo, and some downloaded Revit families. We reviewed the design process for designing actual modeling of building this College of Human Ecology building in the Revit environment. But last week, as scheduled, now we are working on theories in 3D, general 3D graphics and general 3D tools. For what? For design visualization, okay? Design visualization. Still, 3D Max or related applications, mental ray, V-ray, some geometry-oriented visualization tools are really critical for design development for you. So that is why we are dealing with these design issues. But we need to use interoperable way, okay? Interoperability. Interoperable means interoperable between Revit or similar BIM tools and some geometry-oriented design visualization tools, animation making, still image making, fast and powerful renderers, and so on, okay? So interoperable design process, considering interoperability, is still important, but anyway, the topic for today also on design visualization tools as scheduled here, okay? Midterm exam, final project as scheduled. So lab exercise, midterm exam, final project, one of two options, okay? YouTube uploaded video-based presentation or BIM-based design project for your design studio, whatever, okay? What to do today? Theories, lecture, and 7 lab exercises, but actually not that many, not that complicated lab exercises. I think you can finish up easily if you recall, if you remember what we have done last semester, okay? Some intensive review for geometry-oriented modeling as well as renderer, mental ray renderer, and Autodesk material-based modeling. The last one for today is a preliminary interoperability lab exercise. For example, today, Revit to 3D Max, I'll let you know how to use FBX file format for visualizing your design model originally created by Revit using FBX file format, okay? Okay, let's move on. Okay, so far we have learned some parametric modeling, BIM approaches, and related applications. We reviewed some actual design project. Now you know the strengths of BIM, parametric modeling, and related applications. Why we need to use such a technology? Of course, I told you before, some freeform or non-uniform design, they are nowadays very common in our industry. For example, even if this building, Seoul City Hall, awarded the worst design recently, okay? One of the worst design, it's kind of notorious award. I'm not sure the award name, but anyway, it's very controversial. Some people think this building is good surface, but most people don't like this building shape, construction. As you see, construction process, but as I introduced it before, preliminary, original design model, design visualization is looking totally different, okay? Very different actually. Even some advanced developed design model shows something different against this final model, okay? So why this happen? Why design model and construction model as well as the real picture looking different? Let's look let's take a look at another example, another parametric cottonware design example represented by Front Incorporated, the US. Let's take a look this ribbon-like geometric surface shape for building facade. Take a look. There are amount of CVs. CV here means control vertice, okay? Control vertice for controlling their connections. Their connection simply generates edges, okay, lines. And the line, the lines going to be create 3D forms, okay? So controlling control vertice or controlling spline curve simply means edit its final 3D geometry. So glowing ribbon-shaped facade using LED system. Okay, now this is LED, not just a simple material. Anyway, the controllable geometry, even in early phase design, can be defined like this way, and then this one can be realized in actual model. Next example, another famous one is DDP, okay, Dongdaemun Design Plaza. As you see here, interior looking really unique and totally different. In mesh shape, take a look. This mesh shape, searched by simple Google image search, also it's a really unique surface. This is not a simple box shape interior. Of course, exterior facade shape looking totally different, not box shape, modern shape, not linear style. As a result, interior scene also affected by building mass, totally unique and non-uniform. So how to realize this design? Okay, designer Zaha Hadid's her design intent can be resolved in this shape, in this form. But the question is how to realize this building. Take a look this picture. The picture for installing, erecting, realizing this building, you may know how long this building construction has been taken, for 10 years, okay? For 10 years. And take a look, this Korea won money. It's not easy to count, okay? It's really big money. All the money from your parents, okay? Taxpayers' money, or from tax, because this is public building, okay, from Seoul City. Anyway, why this one took so many years and so much big money compared to other general type of buildings? Because each single panel has totally different shapes one by one, but this one has several hundred thousands of different unit modules. Each one has different ratio for holes. Something is solid panel, something has bigger holes, something has smaller holes. They are totally different, totally differently manufactured required, okay? So anyway, Samsung Engineering and some consulting companies incorporates, including Getty Technologies, they prepared certain type of prefabrication process while in actual construction process, okay? Take a look. They try to make real fabrication and real construction before getting into on-site construction. They have researched again and again, lots of time, for making appropriate process, beam modeling, and making some mock-ups, make some forms for concrete, forms for steel structure, and so on, again and again, some recursive way in their on-site lab for real fabrication. Anyway, at the end, installed panels, installed structures, and then, as you see, at the end, this one installed, realized. But what was the problem? the man on-site workers, they didn't experience such installation, such construction ever been before, right? In their life cycle, of course, in your life cycle, in my life cycle, this kind of shape, this shape of building is the first time in forever, right? Another problem is this building never going to be reproduced again on this planet, okay? This is the first and the last design should be realized. So anyone in this place, they are all experts in construction, but they didn't have any experience to this building. How to realize this building, they don't know. But anyway, they try to make it. So eventually, the building erected in this way, but the problem is kind of never-ending question. How to realize this building. At that time, this building was this one. But in your case, in your actual industry, when you got a job in construction, design, whatever, engineering company, your design supposed to be totally different. And that design going to be the first unique design and the last design should be realized in this, on top of this planet. That's our domain-specific problem, okay? But in general, just a box-shaped building, very efficient and very simplified building, so-called boring, typical, stereotyped building. We can make that kind of building for housing, for office. But we don't say that that kind of building has design, okay? They are just building construction. But this one has, of course, its own design. So when you are working with the design team as well as construction team, we always have some problems how to realize that design. So using computers in this kind of BIM and digital design class, our question always same. How to design this building, that's one question. And eventually following question is how to realize that design, okay? Just for fun, I prepared this slide. And do you know this movie? Do you know this? Do you know this movie? Okay, let's take a look. I want to show you this one just for fun, okay? That's DDP, okay? DDP.
And even plastic surgery with millions from all across the continent coming east and every year. And when they do, they make sure to stop here at Dongdaemun.
Okay, news beyond the imagination. Okay, this is the site for DDP. Okay, I told you this is just for fun, but do you know what was placed in this area? Of course, Dongdaemun Basement Stadium. Okay, very old building. The building demolition happened long ago, more than 10 years ago, and DDP has designed for this area. Very unique and sort of historic place. But anyway, many people say that this building is going to be dangerous and going to be very ugly or something unnatural, something opposite to Seoul history or environment. Very kind of very opposite and very negative against the erection of this building. But I think, in my opinion, it's kind of successful, okay? At least this one is one of the landmarks, especially in this area, this building. And the environment is kind of very unique place, and a lot of people stopping by this building, visiting this building, taking pictures, and so on. But I never been inside, getting into this building. I have been passing by this building lots of times, but I never been entered this building. Anyway, really good example, good case when we are learning parametric modeling, parametric design. Okay, let's a little bit talk about more about non-uniform building design, so-called free-form design. Okay, building mass types and non-uniform design. Let's take a look some series of building shapes in categories. I put entire building shapes in 4 different categories. The first category, actually this one contains almost everything, almost entire buildings in the world, in this planet. But actually rest of three categories are so-called free-form design, okay? Non-uniform design. First one is box shape. Take a look. This picture is Manhattan, of course. How about Chicago, Manhattan, 100 years ago, 80 years ago? 80 years ago, Manhattan is, of course, not exactly same, but very similar to this shape. Even 100 years ago, they have skyscrapers. Skyscrapers means high-rise buildings, skyline, okay? But most other cities in this planet, 100 years ago, even there was no high-rise buildings and no skyscrapers, no even cities, okay? Anyway, United States, thanks to many famous, historic, modern architects, including Louis Sullivan, Frank Lloyd Wright. Okay, lots of architect names we should know, but anyway, I can tell you just few names. But anyway, thanks to architects, modernism architects, very efficient, very linear, and something high-rise box-shaped buildings are existing so far, and very typical. That's okay. Box-shaped building has its own efficiency and its own unique features in terms of design, focusing on specific features, specific interior features, shapes, decorations. Anyway, box-shaped building is still very popular and very common design style. The first style of freeform, non-uniform design is diagonal line shape, okay? Take a look, diagonal lines, and they are looking some linear, but of course not box shape, okay? What is this building? Who designed this building? Denver Art Museum, designed by Zaha Hadid, okay? Zaha Hadid is representative designer, architect in this domain, diagonal line shape, okay? Take a look, his design, angled wall, looking scars. Daniel Libeskind, another building, famous building design in Berlin, Juicy Museum, okay? Also diagonal line shaped design. Next category is segments, okay? Segments. You know what segments? Of course, this is segment. Take a look. Rectangle shape, but one diagonal line divides one rectangle into 2 triangular shaped pieces. One single triangular piece has exactly one single plane, okay? So this one, so-called segmentation. Segmentation of freeform surface. Kub Himmelau and some similar architect designers work. Amount of similar shapes in building facade, Kottner system, building surface, building skin system. The last one is free line curved, totally free, including DDP. DDP surface, 3 directional free line, okay, free surface, free form surface. Representative designers are Zaha Hadid, Frank Gehry, and so on. Okay, so we can categorize 3 different style of freeform, something beyond the box shape, okay? What's the problem of non-uniform design? What's the problem of those designs? Design, of course, it's not easy, but comparatively, real construction is also not easy, really challenging. Take a look this design. It's, I don't know how to call the building name in English, but anyway, Busan Cinema House or Busan Film Hall, whatever it is, take a look this design picture, design rendering. Some LED or projection mapping, whatever it is, some displaying ceiling structure in freeform, okay? And lots of wave and some non-uniform curve you can find. But take a look, the final construction of this detail. Take a look. Is this designer's intent? Of course not, okay? Designer's intent totally different from real construction. That's why I put this notation. Design is not same to construction, okay? The problem of this kind of shape geometry is even if on-site workers are very skillful, they don't know how to realize this building. I told you this building design is the first building design ever experienced before to any on-site workers, directors, masters, and so on. And this one never going to be reproduced again to any specific sites. So even if on-site workers are very skillful, if he or she doesn't know how to realize this specialized curve, how to realize this building, at the end, the result, the quality of construction could be something like this, very low and very bad quality, okay? Next case will show you some building, sports complex, stadium for Incheon Asian Game. Take a look, it's looking okay, but if you zoom in, something wrong, right? In higher resolution. How about this one? City, something like city or public building. It's looking okay in this scale, but if you zoom in, if you take a look in detail, something also wrong, okay? Simply because designer's intent couldn't be realized, because designer's intent couldn't be resolved in actual construction documentation, construction drawings, construction model, simply because they didn't use parametric modeling or beam modeling. In other words, drawings, 3D modelings couldn't be useful for actual construction. So this result totally generated by on-site workers, on-site working directors, staffs. He or she is in charge of realizing this structure without any detailed documentation or detailed instruction, totally based upon his or her knowledge, okay? What if they used BIM? What if they used parametric modeling? Even in design phase model, the joint structure or this kind of finishing structure could be represented in detail, okay? And then on-site workers can refer to the structure and the design for realization of this building. That's simply why we need parametric modeling and BIM-enabled approach. So even if this one is not 100% good example, instead I like to introduce you this one as one of the example which has design intent realized in construction phase. Take a look. This is tri-bowl, okay? Tri-bowl design process, and let's take a look at how to design and how to realize this building quickly, okay? This one designed by IARC Design using very representative and famous parametric modeling tool. Let's take a look design process. At the beginning of the process, they said it's kind of reverse engineering based because take a look. This is styrofoam, very soft plastic structure, okay, made by hand. It's weird. This is not computer model. This is just handmade object. And then this one laser scanned. And based upon reverse engineering technology, this geometry could be transformed to CATIA, Rhino model. You know what is Rhino, but you don't know what is CATIA. CATIA is very famous mechanical engineering parametric tool, usually used for airplane design, okay, engineering software. Anyway, geometry acquired like this way, and for rapid prototyping, 3D printing, 3D print outs, and some mass studies, interior studies, building structure studies like this. Of course, some geometry optimization process required. Conceptual design to constructible design. That is so-called optimization process. Why we need to optimize? I showed you before. This design can be designed, but how to realize it? Real site, real world. Without any details, any optimizations, of course, output quality is really low, or sometimes it couldn't be realized. So geometry optimization process is kind of mandatory process. Converting design geometry to constructible geometry, okay? So studying geometry like this, how to subdivide, how to cut, and how to assemble, and so on. Lots of parametric modeling and design approaches. Take a look. This is CATIA interface, and take a look. The point has numbers, okay? Take a look, numbers. Those numbers are kind of control vertex numbers and can be represented in this Excel spreadsheet using numbers. 2 weeks ago, we have learned some approaches designed by numbers, okay? Your design, whatever it is, can be represented by numbers because computer recognizes that numbers are this geometry, okay? So if you update the number and then the geometry going to be optimized or updated, that's controllable geometry, so-called parametric modeling. So the elements are here: geometric shape design, floor modeling, surface pattern design, paneling, structured object hierarchy making, something like this. If you update Excel numbers, specific numbers, location, information, and then geometry going to be simultaneously updated, so-called real-time update, okay? Real-time update of panel details according to design changes. Design change made by design optimization, constructability issues, and so on. Entire numbers here simply say they are parameters, okay? That's why we are saying parametric modeling is here. Okay, let's take a look at some construction pictures. Total 2,600 individually produced panels. Anodizing aluminum panels, okay? Total 2,006 compared to DDP. This building has 10 times smaller numbers, smaller pieces, okay? In terms of number of pieces for building skin. But anyway, this is 2,600 individually produced panels applied for building construction, like this picture, okay? So more construction pictures like this here, and interior pictures. Take a look. Take a look this interior. 3 weeks ago, we went to this site and I saw there is some warning notice, warning sign. Don't climb the wall, okay? The wall has 40 5-degree angled, so looking very sleepy. But anyway, lots of science. Don't climb the walls. Usually walls are 90 degrees, so no one try to climb. But anyway, as you see, some angled walls. And this is also gallery space. In my opinion, my personal opinion, inside of this building, looking really, really unique and special. Okay, you need to stop by this building someday. Okay. Next example, next case is Salvador Dali Museum, designed by HOK and realized by Beck Group and a lot of associated subcontractors. Take a look at the picture. It's BIM project, okay? Especially Revit project. Sorry. Actually, design firm, one of the famous design firm, HOK, around 10 years ago, they made some company strategy. They must use Revit instead of SketchUp, 3D Max, Rhino, any other geometric tools. Okay, they are mandatory tools, even in initial phase of design. Always Revit. Nowadays they use some other tools as well. But anyway, at the end they have to use Revit. That's their mandatory requirements. How about other firms? Parkinson & Wills, SOM, or any other some local architect firm in Korea or other countries. Nowadays, the more companies, more people mandatorily using BIM tools, such as Revit. Okay, but HOK is one of the leading companies in the world. So even 10, 15 years ago, they used Revit for their fundamental preliminary design tools. Anyway, take a look. Actually, this is remodel. Original building shape was just a box shape, okay, simple box shape. But building core and main lobby space, it's very unique space. Take a look, this picture. What is the tool for this one? Of course, it's Rhino. I think they use Rhino at the beginning of this form studying, form making. Possibly with Grasshopper too. Anyway, design and construction phase. This is the visualization, design model visualization, not that complicated and realized. But even if it's looking design model, this is BIM-enabled design approach and parametric modeling. You already studied how to make this kind of triangular shape for flat surface individually, even if surface design is any type of freeform. And this is Revit screenshot, okay? So let's take a look some design model, design visualization, originally represented by Revit. The structure represented in this design tool and realization of the realization picture, design model and the realization structure, it's exactly same, okay? Some details could be different anyway, but basically the geometric shape represented in this design model and the construction picture, construction model, they are all consistent, okay? That's the point. That's why this construction could be done by even from design model. Take a look at the picture. The picture, triangular flat surface, this kind of cardinal panel. In the lab exercise, actually not today, later on, we're gonna make this kind of freeform surface in Revit as well as 3D Max rendering. But anyway, my point here is Revit-based modeling applied for this building and realized like this way, okay? Real case. Take a look, this is Revit model, okay? Without that unique design structure as well as extracted ceiling and integrated ceiling. Take a look. The structure here is looking just geometry, but this is not just simple geometry. Any single line here is exactly same to real world fabrication model, construction model, okay? That's important point. That's the difference between BIM-based design approach and geometry-oriented design approach. If this is just a Rhino model, 3D Max file, AutoCAD file, no one guarantees this single line, any single this line, going to be realized or not. But this is BIM model, parametric modeling based model, which means the number of pieces defined here supposed to be realized. In other words, picture and this screenshot going to be exactly same. Okay. Okay, obviously BIM and other advanced design computing technologies are very promising way to go. But we still need to visualize, okay, design. Sometimes using Revit, using parametric modeling is looking something heavyweight, okay. Sometimes we need just single plane, single box, and some fake environment in order to make some realistic and easy to make visualization outputs. That is why we are handling design geometry tools, geometry-oriented approaches, design visualization tools, rendering tools, and so on. But eventually, my point in my course, in my courses, is simply I like to let you know some interoperable working process. When you need to create building model, building project, Revit or Revit-like BIM tools going to be really useful for modeling your project. When you need to visualize, you have to know how to use Mental Ray, Autodesk Material, V-Ray, and so on. Cloud-based rendering. Easy to make visualization approach, okay? So, simply say, you should know several ways, many ways to do everything, okay? For design development, modeling, visualization, rendering, even animation making, video-based presentation, all they are your subject in design computing courses. Okay, let's have a quick break and then move back to the slide, okay? Okay, go back to the course material, course slide. 3D computer graphics and visualization of your design. I told you, even if we are dealing with building information modeling, advanced technologies in design computing, building information modeling, parametric modeling, but still we need to visualize design in an easy way, okay? Convenient way. So, computer graphics and design visualization is still very important, very critical. It has really bigger role in entire building life cycle, okay? Even in early phase of design, planning, specifications, we need to prepare some visualizations in terms of design representation, design presentation. In design drawings, planning, drafting, reviewing, analyzing, simulating design for construction, construction planning, documentation, cost estimating, quantity takeoff, scheduling, clash detection in design simulation, for the construction simulation and scheduling, and real construction, including real operation for several decades. Building life cycle, design visualization is still very important. So what type of visualization by computers in terms of rendering? I told you before, rendering is all about lights. And take a look left side images. Those series of 5 very simple representation contains almost everything about renderings, okay? The first one, line stroke, line drawing, that's one type of rendering, okay? Line stroke rendering, line stroke based drawing style rendering. Next one is color shading, okay? Colored rendering. The third one is shadow casting rendering. The fourth one has texture map, okay? Texture map rendering, and the last one, ray trace, okay? Ray traced for photorealistic rendering. So very different style of rendering, but they almost say everything about rendering. And light things are some elements, okay? Lights, target objects, camera, that's all. Under lighting, we have to take care of something about lights. Under target objects, we need to take care of something. They are all structured in this way. Okay, all those slides are totally something about visualization. How to visualize, how to make some renderings using this tool, Autodesk 3ds Max, okay? So, what to do in 3D Max? What was for? First one, geometric modeling. The term modeling here means geometric modeling. Secondly, of course, visualization, rendering. The third one, animation making. But actually, animation making is same to rendering, but this is still images. This is sequence of images, okay? Sequence of rendering. So each component under modeling, very hard and time consuming. Rendering, many things to take care of, lots of techniques you need to know. Animation, it's hardware dependent because it's really time consuming. Even one single scene rendering takes time. How about 30 scenes for 1 second? How about 60 minutes animation? Really, really long time. Under modeling, create 2D geometry and 3D objects, importing geometry, managing geometry. Under rendering, material, light, camera, and render options. Lots of things you need to know. This is 3D Max 2009 interface, and this is 2015 interface. Actually, there is 3D Max 2016, but not 3D Max Design 2016. Probably 3D Max Design 2017, okay? Design version has Arc and Design, architecture and design related Autodesk material and presets. Preset means predefined environment, very useful for designers. Also remember the hotkeys listed here in this page is the hotkeys displayed in this page are mandatory, okay? Alt W, Z, F3, F4, C, plus minus, Q, W, E, R, H, Control A, space bar, M, F10, Shift Q, rendering, Q the rendering. So all those hotkeys are very critical, important, basic interface, and use scenarios for 3D Max. I introduced you this one before, last semester, 3D Max use scenario for interior architecture design. First thing you need to do is defining UOD. This is not a BIM tool. This one doesn't know your site. This one doesn't know where is your building, okay? This one even don't understand you are designing something about building, okay? This one doesn't know anything because this is dummy geometry tool. So your universe of this course, your mini world, your universe, your mini universe defined by you is the universe for this environment. What is in your mind? Roughly sketch, freehand. And then modeling. Modeling universe, modeling environment first. Usually a fake environment, okay? Some fake inside of box or something fake exterior view standing outside of your window. That's it, okay? That's modeling universe issue and modeling design elements, your target objects, your target design component. On the environment, there are planes, walls, sky, outside view, fake outside view, okay? And also design elements in 2D, 3D, sometimes importing geometry, 3D warehouse and families and so on. And time-consuming modification. On the rendering, lots of things take care of, material, lights, camera, and some rendering techniques, okay? And retouching in 2D graphics tool. Photoshop or other tools to maximize your visualization, your visual meaning for design. For interior architecture design, I listed up more something scenario, user scenario. Okay, defining UOD modeling is hard and tedious, so that's why we need to reuse some given geometry or existing geometry, some basics about rendering, and something about retouch. As you know, we are using Autodesk applications. All the material here simply shows you some. This one is Autodesk material, okay? Revit is Autodesk application. Revit also uses Autodesk material in its visualization, in its rendering, which means if you model your objects in Autodesk Revit, and then if you export specific file format, and if you import that file into on top of specific applications such as Autodesk 3D Max, what if your material is still alive? That is why we are using FBX file format for one of the today's lab exercises, okay? So entire material assigned in Revit still alive in 3D Max, okay? For your design visualization. But lightings are something different. So what we need to do is controlling camera and controlling lights. That's elementary level edits interoperable work from Revit to 3D Max. That's today's last lab exercise. Okay, anyway, thanks to Arcane Design material, Pro material, so-called Autodesk material, we can use something interoperable design visualization thanks to Autodesk material between heterogeneous applications such as Revit, Family Editor, Dynamo, and 3D Max, Mentalay, and so on. We also reviewed graphical user interface issues and some changes in user interface issues. Ideal interface for 3D is NUI, partially GUI, 3D laser scan, photogrammetry, something beyond the keyboard and mouse. This is ideal, but in reality, we have to type numbers, we have to click buttons using amount of functions, representatively 3D Max interface, okay? So the gap between ideal interface and real world interface makes you hard to get 3D geometric modeling and so on. But the actual reason is here: ray tracing, global illumination, shading, bump mapping, Bezier curve, non-uniform rational B-spline, CV points, segments, polygon, sweeping, lathing, something about camera, some concepts in tech mechanisms in lens, focal distance, what's the meaning of exposure value, what's the meaning of aperture, and so on. Without understanding, without knowing such behind the technologies, you have to always memorize clicking sequence for design tools, modeling tools, rendering tools, again and again. But if you understand behind the technologies, you don't need to memorize user interface issues. User interface can be learned by Google image search or Google tutorial search or YouTube video tutorial in 30 minutes, 1 hour. That's enough. Because behind the technologies always the same, okay? Even if Blender, Maya, Rhino, Digital Project, Revit, 3D Max, they all have different interface. SketchUp too. Behind the technologies are very similar each other. So understanding the logic, if you understand the logic, rather than memorize the order of clicking sequence, you can learn any software, okay? That was my point, as always. 3D geometric modeling and modification using geometric components and parametric modifiers. Actually, some primitive geometry here, we used to use those given geometry as well as amount of modifiers or options modifiers on the 3D Max editable poly approach using some controlling subgeometry. This image is also very famous last semester. We need to control vertex edge, especially polygon edit for modifying your geometry. Okay, this box shape can be created and modified by lots of several subcomponents. How about this one? Some noise, some fractal, some automated modifiers creates this kind of geometry or modifying your geometry similar to FFD or some knobs curve. Today's lab exercise also we're going to apply those techniques. And some patterns, fractal, those things. Actually, we're going to quickly move to the next slides. We're going to deal with this one in lab exercise, today's lab exercise or next time's lab exercise and so on. Okay. So amount of some parameters, some behind the technologies, some algorithms predefined by 3D Max, wrapped by specific modifier. At this time, noise modifier. Okay. Fractal enabled noise modifier and so on. For interior architects, here I list up user scenario again. Firstly, create background universe and architectural environment creation for import geometry and editing, creating geometry and design elements and rendering and retouching in this sequence. Okay, so that's why we need to take a look some 3D Max interface using this fundamental scenario, fundamental approach. This one shows you the most important thing, units. Okay, if you create several kilometers huge objects or too tiny objects, lighting or some other options going to be really affected to your final visualization. And this is one example of your fake environment, sort of virtual and fake environment. Simple cylindric shape, very large cylindric shape, and remove top and bottom. And this one can be filled with the picture for environment. And your object, your design thing could be placed exactly middle of that environment. Okay, this is so-called fake geometric environment. And your geometry elements can be controlled, and you can use rendering tools, V-Ray, Mental Ray. We're not going to deal with this one in detail. We're going to deal with those parts in actual lab exercise for today. Okay, anyway, learning, training, 3D visualization, of course, should be sort of self-trained, okay? Refer to a lot of professional websites such as cgarchitect.com, 3dtotal.com, and so on. cgarchitect.com is one of the representative websites, something like this, okay? cgarchitect.com's example. Another example, 3D Max rendering to visualize this scene. And take a look. 3dtotal.com provides you this kind of tutorial. This is final render output, and this web page will show you detailed procedure and detailed tutorial how to make this one, okay, in 3D Max interface, V-Ray interface, or even Mental Ray interface, whatever, based on your choice. 3dtotal.com website's another example shows you this visualization. Take a look. This geometry is 3D Max geometry. Based upon the geometry, amount of visualization example created by this application. What if this is Revit model, originally Revit model, and this one transformed to 3D Max or rendering environment? Creating this geometry in 3D Max, probably now it's going to be more overburden to you. Creating geometry using Revit is much convenient and architectural, I think. So reuse the geometry, even in geometric modeling tool, visualization tool, is the matter, okay? Refer to professional documents defined by some more PDF files and so on. So I think we can move on to the lab exercise, okay? We have lots of lab exercises for today. So let me finish the lecture quickly and then move on to the lab exercise.